Thank you everyone for your questions. And now I'd like to introduce our next speaker, Mahesh Venkataraman from Accenture, who is going to present us today with a system-theoretic approach to mitigating epistemic distortion in LLMs.
And please let us know if you agree with the recording.
Yes. Can you see my presentation, the slide?
Yeah,
Yep.
we can see your slides.
Okay. So I come from a technology background. So I'm not a philosopher, but I take a deep interest in confluence of philosophy, technology, and other humanities with technology, because I see technology systems not so much as technology, but more like a socio-technical system. So the way I look at today, the way my talk is going to be centered around, as a technologist who has interest in philosophy and epistemology, especially how can we work together to make LLMs work. So bear with me if I sound a bit philosophically ignorant, but I'll do my best to um, give a very sound um, lens of the technologist. So about myself, as I said, I love to talk. I mean, apart from my regular work in technology and consulting firm Accenture, I work on cloud and distribution systems and application of AI and software engineering. I love the whole thing of how do we take a system approach to things and how do we solve problems. There is so much talk about whether AI is sentient, whether AI is intelligent or conscious, and which is today very interesting. But in my view, I would work with philosophers to see how do we make AI work for us? How do we take care of the risks and the issues, what I call the epistemic distortions, and how do we work around those issues? Because it is here to stay. The last few years, we've had a couple of years, so much interest in LLM, application of LLMs. And just to put this thing in perspective, many of you would already know, LLM is primarily a language model which looks at connections and relationship between language and semantics. And the Gen AI is a larger term within part of which houses LLM, which helps us to generate content. And the traditional ML and AI has been always based on pre-training for a particular purpose. But now with the way LLMs have evolved, LLMs seem to operate like our human mind. We think symbols, we think language, we think in terms of connections. Whatever I talk, it's not isolated. Mahesh is related to X, Y, Z, so Mahesh makes sense. Or what it say is related to what you already know, makes sense or doesn't make sense. So it's all a connection, right? So LLMs seem to work in the way that we humans think, and that makes it so powerful, and also often, I would say, risky, right? Just a minute. Yeah. So, so as I said, right, how can technologists collaborate with epistemologists, philosophers like this great audience here, social scientists, because AI today is more and more a confluence of disciplines, because the way we understand AI, operate within the world of AI, needs to have technologists like me have to have a working knowledge at least of the sciences, the disciplines that I have indicated here: phenomenology, psychology, cognitive science. And how can technologists like me make it easy for humanities people who are very creative, who think? The people on this call are thinkers, whereas technologists, we think the entire world can be captured by formula, which is not always true. How can we combine creative thinking with critical thinking with creative approach? So this is the point of my dialogue, and it's very interesting because a few years back I came across Searle's Chinese room argument and symbol grounding problem. Both Searle was a philosopher, and Harnard was again a cognitive scientist. So the question here that they asked 20 years back was, can I can I talk as though I know Chinese or any language based on the patterns and connections in the language? Can I appear to know Chinese or any language, Romanian or Hungarian, whatever language, based on the connections without knowing anything about the language? And simple grounding problem is, all about, many of you already know is, what is a dog? A dog, has an identity in relation to something else. So is it really meaningful? Do I understand? Does LLMs understand? So the LLM implication here is there a grounding the way LLM talks to me? Is it really conscious? I say LLM, I'll tell ChatGPT, you're so intelligent, you're so great. It answers to me as though it's real, but is it really real? Does it have a true understanding? Is it grounded on sensory motor reality as we are? Is there a cognition? So those are the questions that we have to ask. To me, the answer seems to be they are just connectors. LLM works on the next best at the very ground foundational level. LLM works on what is the next best probabilistic word that makes sense in the current context of the conversation. Now, it's difficult for me to accept that LLMs are conscious. Very difficult for me to accept that they are sentient or they are intelligent, they have emotion. Do they have intentionality? I don't think so. But leave aside that part. How do we make it work for us? That is the biggest question, right? So this is generated by ChatGPT. If you look at it, there are lots of things that are marked as yellow here that seem not very right? And without going into the details, just to summarize, so something like authority laundering. It says recent neuroscience has confirmed no specific studies are indicated. It is a vague, and temporal flattening is, it's kind of tries to collapse concepts or events in time and tries to present to you in a very simplified, oversimplified language. Like it says, a landmark study by WHO in 2012, even before TikTok came, the whole concept of social media then was very different from after TikTok came. So really cannot conflate these two. And then mental health is no longer an individual condition, but a system failure. So sweeping emotionally, but everything sounds so convincing, right? And the classic problem that we all face as technologists and philosophers is correlation is not causation. Because wherever there is fire, there are fire engines. Now, does it mean that fire engines cause fire? The classic problem in medical sciences is fever a consequence of infection, or is fever a corrective mechanism of the body? So this problem will remain always, correlation, causation, because it's very difficult for us as human beings to really comprehend complex phenomena wherein we are able to understand and distinguish between correlation and causation. Simple things like, if I push something, it moves, I can understand causation. But complex systems, we'll talk about complex systems in a while, difficult. And LLMs are notorious for sometimes confusing these two, and that causes wrong understanding or epistemic issues, a generalization and things like that, right? So now I'm going to make a bit of a risky statement. When we talk about epistemic distortions, which is primarily authority laundering, temporal flattening, and coming across as so coherent, but plausible, but not necessarily grounded on truth, to me, in LLM, when you use LLMs for, say, in your organization to evaluate grades or to write research papers, there are trade-offs. And nothing like good, bad. A distortion arises out of wrong optimization or misoptimization. For example, when something is very polished and very summarized and makes sense to somebody who is a lay person, but for a medical system, that is not good. So what is right in one situation could be an epistemic distortion in another situation. Similarly, when we talk about how did the World War II happen, you have to have a summary. You have to have a bit of something that I am able to understand as a war specialist, or how does war happen. But in real sense, I could be collapsing a lot of things in time and kind of presenting it as a, oh, this caused World War II or World War I, right? And then many times we come across very, very plausible, very clear, very confident answers from ChatGPT, Cloud, or Gemini, or anything. But then, there could be deliberate filling up of gaps. But then the question here is trade-offs. What is okay in one situation could be epistemic distortion in another situation. The classic problem we all have as technologists, philosophers, or any kind of profession is, how do we traverse abstraction, summarization and detailing? And when is a summary, any summary is going to obfuscate or hide details, and any details could miss out the bigger picture. And anything that I learn very fast over time, I could be missing out a lot of information, right? So this is the, I would say, the trade-off, which is the basis of what I'm going to say in the next few minutes. Hopefully, you will be with me. So I have put down more trade-offs here, generality versus specificity, fluency, fidelity, coherence, truthfulness. So you could just go on and on, speed versus depth. Whatever issues you see here are very issues that we human beings face. When we talk about an expert, some people call some people expert. Others may say, no, he's too general. Or some people may call somebody, he's so detailed, he gets lost in details and doesn't understand the bigger picture. Or you could call somebody, he learns very fast and he's able to quickly pick up things, but often he misses out the details. Exactly the same problem we see in LLMs today, because LLMs are designed to think in terms of words and symbols, semiotics and semantics. And this is the reality that we have to address. So let's assume that epistemic distortion, let's kind of come back to the hazards, in epistemic distortion. There are so many issues, right? Apart from the three major ones I have put, of course, there is bias, of which gender bias, economic bias, any kind of bias which is uncalled for, which is unethical, immoral, illegal. That part I'm not covering now because that part is very well spoken about. So LLMs often tend to create a synthetic reality, and this synthetic reality could be termed as summary, or some kind of a different situation could be a desirable thing, but in many situations this could be a problem, right? So these are so epistemic distortion we have to address in a certain way. Now, coming back to the research context, so there are controls today in LLMs. As philosophers, this group can understand that these controls have to be put in place. Now, the question is, do we look at LLMs as an isolated component, or do we look at LLMs as part of a larger system, wherein we take a very system theoretic approach, a control theory approach? I put down here, there are four major areas in which, whether you are a researcher or a space scientist or a philosopher or a lawyer or a technologist like me, this is how we can control the output of LLMs. But we get lost if we go into a lot of details. So first of all is a prompt control. So you can have prompt, from a research perspective, you could say, I am a researcher, I need some hypothesis, I need some initial problem questions, right? Or I need examples. Then I kind of start to give it a chain of thought prompting. Or I say, look, I want you to think critically, Mr. LLM or Ms. LLM, I want you to think critically. And can you counter me on this? Can you give a adversarial response on this? Can you give a counterfactual? So you control LLM in the way you want as a profession, as a professional. And then you can create temporal anchoring, saying that, look, do not conflate some philosopher, Plato, with some modern philosopher. Do not compare these two, keep them separate, analyze them separately. Second is generation controls. Now, this is very, very interesting. And unfortunately, we don't have time to go through all this. So you can control the output, generation through, say, parameters like temperature. Temperature is primarily a trade-off between linguistic determinism, creativity on one side, being quite wild about thinking very creatively versus very deterministically. Suppose you want to ideate, you want to apply lateral thinking, so you kind of increase the temperature. Now, top P nucleus is primarily how do we trade off between the words. How many words, for example, temperature is like I could put anything on my pizza, but then nucleus is primarily you limit the number of toppings on the pizza, right? So between temperature and top P and top K, you're able to control the creativity, the stochasticity versus very specificity. If you're low temperature, low nucleus, you may have very boring, very well known, everybody agrees, a cat is a cat kind of stuff, right? I mean, something that you already know, there is no creativity, but you're too wild there. On the other side, you could have very wild assertions. So somewhere, depending on where you are in your research cycle, you may want to control this. Now we'll come back to the system approach. Similarly, you can look at the responses, how much verbose you want in your answers, then how much repetitive repetition you can allow in your answers. So these are all controls that normally we don't use in ChatGPT, but in an enterprise edition, you could start using it. Then you could have a model selection. Depending on the kind of thing, you could have different models for different application. There's something called RAG, which is like a vector database wherein you store your university or your department context in a database and then tell LLM, please look at this. This is my context and do not go anything beyond this. This is how I want you to create a boundary around what you're going to tell me, right? The third is filters and validator. You could have separate programs or another LLM to validate this, like adversarial plagiarism. And so these are the four broader things. Now coming back, if we apply these controls in isolation, then we are losing the bigger picture. So we'll have to ensure that we take a system in the way that I've defined it here. It's like a system is much more than the sum of its parts, because each component in a system is intelligent and interacts with another system. So there is something called emergence. So the output or a behavior of a system, a complex system, often is indeterministic. And sometimes it is good, sometimes it's not so good, depending on the context, because emergent properties cannot be predicted. This happens in complex technological interconnections. It happens in society, happens in traffic. They're all systems, right? So how do we approach this? How do we address this indeterminism, uncertainty, through using system theoretic approach like MIT, Cambridge, Harvard's STAMP, which is what I'm going to talk about now. I've defined the problem now. I've defined the problem in a certain way, and I have said, look, we have to approach it in systemically, from a system theoretic approach, right? So from an MIT perspective, and earlier this year, I gave a talk in MIT about technology, because MIT, this STAMP framework or STPA framework is typically used for aviation accidents, but it can be applied anywhere in any context, because aviation is very fascinating because it's got so many things: cognition, pilot cognition, avionics, mechanical, structural, air traffic control, HR, human resources. So air accidents don't happen because of single root cause. Similarly, the hazards of the risk of LLM don't necessarily happen because of only LLM. It's a socio-technical network, as I call it, right? Because of emergent properties, you have to start. You cannot just say, I will focus on one thing and I'm going to control the whole output, right? So typically in a STAMP network, what we do is we define the purpose, we define the system first, and then very important in STAMP is we assume that the system, even though has been designed individually not to fail, as a system, there will be failures. So we have what we call the control structure. We create a control structure. This is very important in STAMP, and we will see how we can use it in a typical. I'll take an example case study of a university. Right? And then we say this control structure is like a monitoring structure, and it has got, in what ways this control structure can fail to ensure correct, desirable behavior of this system. And then we look at stakeholders and we identify losses. In this case, a loss doesn't necessarily mean loss, financial loss, or life loss. It could mean what is not desirable to you as a stakeholder. And then we go on to creating something more, which we will not be able to detail out here, but it makes sense for us to have a high level view of how a system approach can help us in using LLMs desirably. Let's take that we are in your university, you are using LLM to assist research. Now, this is, I know, very controversial, because there has been, in my conversations with my academic community, many academic community people say, look, I want to start using LLM, that is here to stay. And some others say, look, I don't want to use LLM because by very nature, it is encouraging laziness, encouraging lack of critical thinking, encouraging copyright violation, right? Now, I'm going to say, how do we make it work for you without violating legal compliance, moral, ethical, or any kind of hazard? When you say hazard, not necessarily life hazard, right? So AI has biases and epistemic distortion we must accept. Traditional view. STPA, MIT stamp STPA view is system lacks adequate controls for epistemic integrity. So we kind of put the whole thing back into ourselves and say, how do we create a control structure? Instead of calling it bad or good and getting lost in that argument. And then everybody comes together collaboratively, having a common mental model. Today, technologists, philosophers, social scientists, cognitive scientists, psychologists, phenomenologists, we don't have a common mental model. We all talk in our own silos, right? How do we make all these people work together now that LLMs have far reaching implications beyond the technical world, right? So we kind of initially model the system. We have the LLM, we have the application. In this case, application is some kind of application to help you create research papers. Then you have the inputs, then you have the outputs. You model it as a human organizational socio-technical network. And in this particular case, you have university, you have your department, then you have the professors, the researchers, scholars, everybody part of this system working together to make LLM work, right? So again, as I said, it's all a multidisciplinary. There's a lot of work to be done, right? This is not about I have a solution today and tomorrow everybody can go and say, yeah, happy LLM can make it work, right? So here is a very simplified using the MIT stamp, the STPA framework. I made it very simple. So you identify the stakeholders, in this case, university researchers and scholars. You identify what is important for them, losses, what if not done will lead to a loss for them, which could be reputation, academic reputation, non-reproducibility of research work, or spurious copyright violation. And then you look at what are the hazards. Hazards are conditions, like, for example, if you're driving in snow in Romania, snow is a hazard, but not necessarily that a snow will lead to always an accident, but it's a hazard. It can enable accidents. Then you have the constraints, which are something like a specification in the system to contain the hazard. Then you have the control actions, like this, how do we control the whole process, and the feedback. Now, at the first look, this may seem like a very, very simple, I've already know it. But STPA stamp gives more rigorous approach to this, and then gives you, for example, it says, do not look at component failures at this point. Look at systemic approach. Do not say this will fail or that will fail. So it starts from a very highly abstract approach to more and more detailed down to the individual and interactions. As interactions, the interactions often cause the failures, right? So you have ideation, hypothesis refinement, literature review, final writing. I made it very simple. Obviously, the people here on this call are much better knowledgeable than me. You can refine this research process much better than me. So you have policies, your guidelines, and how do we ensure these policies and guidelines are correctly translated into prompts and configuration which the LLM control can understand? And how do we ensure at every stage, every stakeholder in the control structure gets the feedback? So we have the feedback loop here and the control loop here, right? So example here, we will not go into details. So for a researcher, what is the loss? I have put propagation of unverified claims. By the way, don't worry about this L1 and, not in the correct order. I generated a huge document and then I kind of, removed some lot of details to make it simple. So basically, this is to identify the loss. So you have misalignment between research intent and LLM generated output, epistemic diversity loss, and publication bias, and so many things. You can identify all these losses. And then you can say, what are the hazards? What are the events that will likely contribute to the loss, like bias reinforcement, overconfidence from fluency. So all this, when you do this, then you go on to how do we create, define the constraints in the system, right? And it's important at every stage, they should make sense to a non-technical stakeholder. At no point, we want at this point get into deeper technical design controls. These are not design controls. Design controls will come later after we flow it down to the details, right? So now, for example, unsafe controls. So when we identified the controls here, control actions, and then we have to look at 4 types of unsafe controls. Controls not provided, control provided, but not correctly, control provided too early or too late, or control provided but too long or stopped too soon, right? So look at this, how it's very simple, very commonsensical, yet it has all the elements of control here. This is from a philosophy angle, common sense angle. This is how we control our life. We don't provide control when required. We don't. We stop control, whether it is interaction between family members or university students and teachers and professors. It makes a lot of sense to you. And then you look at not providing or providing too early, too late. What are the associated hazards? So at every stage you have a traceability between hazards, losses, controls, unsafe control actions, and the final design intent, right? Now what I have done here is just to make the point. Obviously, we don't have time to go through it in detail. I want to stop quickly here so that we can take questions. Is at every stage in the research step, for example, when you want to start to identify research questions, you want the temperature to be high. Temperature, remember, is a control in LLM, and top P is also control. So here you want it to be as creative, but within boundaries, right? So you can set something, and these parameters are to be set by discussion between the philosophy department and the experts, right? Now, when you refine the hypothesis, you want it to be more precise. You don't want it to be wild, you want it to be logical, factual. So you kind of reduce the temperature, make it more deterministic, and then you only look at what makes a lot of sense for you as you narrow down your research questions into hypothesis, right? Refining the hypothesis. So on and so forth. All the various checks, all the various controls that I listed previously, they can be tweaked based on the phase of the research. Step 1, step 2, step 3. And then this will be done automatically.
Mahesh,
yeah.
Could you please wrap it up in a bit?
Yes.
We are running behind schedule. Thank you.
Yeah, sorry. Yeah. So final takeaway, last slide is, we have to take we cannot take an isolated technical approach. We have to take a more system level, looking at as a socio-technical system. We have to look at LLMs as an actors in epistemic ecosystem and not as an isolated thing. We apply systems approach, and we build reflective control structures to ensure that LLMs give you what you want. And finally, very important is we take a transdisciplinary approach. Let me stop here. I hope I am on time. Thank you so much for the opportunity. I just loved interacting with you all. I just love to see so many philosophers here. I'm so thrilled.
Thank you so much for your talk. I did find it amazingly interesting, and there's a new perspective here. Just talking about academics usually gets on the same level, but due to time constraints, we can take one really short question if anybody has any, and after that, we'll move to the first keynote of the conference. Yes, Andre, please.
I'm sorry, I've got all the questions. Thank you so much, Mahesh. A wonderful talk. I really enjoyed it, and I think it's absolutely sort of eye-opening. My question is a bounce back. It's a question to you, just from the glimpses you've had of the philosophical and metaphilosophical debate surrounding LLMs. Just what do you think best fits the practical issues you've broached upon? Where do you think most contact could be made between what philosophers talk about and what most preoccupies you?
So we to say what is the best way to collaborate? Is that the way I understand? Because okay, I think we have to take a specific, small, well-bounded problem, university that is bothering the universities or any university, whether it is Bucharest or any university, work with the industry and then start to encourage this transdisciplinary approach to things. We are too siloed. To cut this long answer short, because we are lack of time, and definitely I want to talk to you offline, Andre. We have to take a small bounded case study or a pilot and start to build people together and take any system approach and then start to apply it. We have to start to doing it.
Yeah, so just as we speak, some of our colleagues are putting together a guide for students about how to use LLMs in their educational practice. So I think this is more than welcome. So I'd be very happy to follow up with you. Thank you.
Absolutely, looking forward to working with the university. Thank you so much. Sorry about this, overstepping my time, and looking forward to meeting all of you in person and talking to you over digital channels. Thank you very much.
Thank you so much.